of what we were doing. So to determine what were the best existing elite Asian varieties in terms of their resistance to CMD, and work on getting those into farmers' fields and working on the extension information. Secondly, we were lucky to have varieties from outside our target regions with resistance to CMD, and we'll hear about the evaluation of that material today and whether it then informs our first kind of strategy. Are we now moving some of these resistant varieties into the seed system? And then, of course, through conventional breeding, which is mainly happening in Thailand and Vietnam and Colombia, we're hoping that we will soon be having varieties that have been crossed during the project entering into the evaluation. So today we're going to hear from Xiaofei, who's presenting on behalf of the team in Vietnam and consolidating those results. We'll hear from Dr. Chilompol about the very recent harvest in Thailand. And then I've asked Rick just to present some of the results from the agronomic trials in Kampong Cham, just so we have a benchmark of what the current varieties are doing and what that means in terms of whether varieties coming out of the breeding will be of interest to farmers. So hopefully we can get to the discussion and have quite an interesting discussion. Please participate and feel free to provide your views as we develop our plan together. Just to remind you, the project, of course, has the different components, and today, whilst we're mainly hearing about the breeding, we're working towards the seed system, and we've also been doing some work, a lot of work on the seed system with the development of the rapid multiplication, and we've actually in Laos recently done the first distribution of material which hadn't come out of the rapid multiplication sites but had came from the fields where we're doing it. So the system's in place for these varieties to be released. As always, please feel free to share your views and your photos. It's as close as we get to the field at the moment in the other countries, and I'm sure everyone loves to see what the other teams are doing, so please stay connected. And with that, I'm going to ask Xiaofei to share his screen and lead us off in the presentation. Xiaofei.
Okay, thank you, Jono. Can you hear me?
Yes, can hear you well.
Okay, good. So my slides are in the presentation mode?
Yes.
Okay. Thank you, Jono. Thank you very much for organizing this meeting. So excited to share the result we get mainly from Vietnam. We're collaborating with EGN and Hanlock. So I think before kind of at the beginning, just briefly discussed the breeding activities at CEAT. So we know globally the cassava product, for cassava there are 4 different products. So they are by fortified cassava for high beta carotene, and the good clean quality cassava for fresh human consumption, and high and stable dry matter cassava for industrial use. And we also have waxy cassava. So for these 4 products at CEAT, we have 7 breeding pipelines. Basically, for each product, we have about 2 breeding pipelines. One is for Africa or Asia, so the other one is for Latin America. So for Africa and Asia, they require CMD or CBSD whitefly resistance, and for Latin America, we might only there is no these two disease. So today, here we mainly focus on this high and stable dry matter cassava. We have for the long term goal, we are going to provide improved breeding populations to national breeding programs in Africa and Asia for these high and stable dry matter variety for developing the varieties. And in terms of plant breeding, so there are four major components. So product profile is kind of guide us where we should go, and we have a strong team. We have scientists, plant pathologists, physiologists, and also work on agronomy, seed scientists. I think all the scientists are here working on ECIR project. So today, here I mainly focus on the germplasm and also the tools. For the germplasm, mainly talk about the populations we evaluate in Vietnam. And for tools, briefly talk about the validation of CMD2 markers. So last year, we also have a meeting to talk about the breeding. We introduced kind of these 6 source population for CMD resistance. So we introduced IITA clones, and years ago we introduced this kind of 3 CMD resistant clones, and also we are in the survey. I think we did in 2015. We also identified from that population. We also identified 10 clones showed good CMD resistance. And the 4th population is 102 CED population is divided from TME3. It has many clones has CMD2 resistant genes. And also we introduced seeds from Hawaii that's supported by the Next Gene project. And we also test the germ section with AGI. So today I'm mainly going to report the result we identified from these the clones from these 4 populations. So in 2020, we established kind of advanced yield trial using the resistant variety we identified previously. So this 24, I think is 36 clones are the resistant clones from CED 102 population, and also these 2 clones are introduced earlier, and 5 IITA clones. They showed good CMD2 resistance for sure, and also the Czech or the elite released variety in Southeast Asia, and these clones is identified from the survey. It has good yield and also relatively good CMD resistance. Then we use kind of advanced yield trial design. I'm going to talk about it later here. So we plant the trials in May. It's kind of the rainy season, the major planting window, and harvest in March in the dry season. 2 locations, Tai Ninh and Dong Nai. The source of stem cutting is from Tai Ninh, and we use a row column design with 3 reps and 20 plants per plot and 4 rows. And we only harvest the central 4 plants for yield. We record the different traits like germination, CMD, severity, and also height of the first branch and branch number. This mainly show us the plant architecture, and we also record for sure the dry matter yield and number of rotted roots. All this. So here again, it showed the location of the trials, Tai Ninh and Dong Nai, and the trial design. I will just quickly go through this, and the traits we recorded after planting, before harvesting, and also during harvesting, and 2 locations. So we analyze the data location by location. So the first, based on the row and column information, we can and also we have 3 replications. We can figure out the field variation. For example, this is the yield from tannin. You can see the field variation. So this part yellow is 10 ton per hectare higher than the population mean, and this part the blue is 5 ton lower than the population mean. So we adjusted the field variation to get the BLAP value for each clone. So you can see, compare with the raw data, you can see some yellow color in this part. So, and also again, this is yield for Dongnae. We also saw some yield field variation, and we adjusted. Kind of similar story. This is for dry matter. After we adjusted the field variation, then we compared the two locations, and this is the CMD data. You can see in Dongnae 1 month, 3 months, 6 months, the orange bars is in general it shows the lower CMD pressure, and tannin is in general is higher CMD pressure. And also for plant height, Dongnae is much higher than tannin. It might be related with the soil fertility. The soil fertility might be much better in Dongnae than farmer field in tannin. And the starch in Dongnae is a little bit lower than tannin. Okay, so this kind of show you the data quality we have. In general, higher heritability, it should means the higher data quality. You can see even for yield, we have about 0.7, 0.8 heritability. So AJ Hanlock and also Dewey, they did a great job to collect the data. Then we can make a relatively good decision. So here I showed the correlation between the 2 locations for CMD. It showed very good correlation. So these are the released variety in Southeast Asia. Is mainly have higher CMD score in both locations, and these are the resistant varieties here. So it's kind of gathered here. And then we have a close look at the starch. It's here, yield is here, and also the starch yield. So for starch, in general, we can see the pattern. So it's high in one location. In general, it's also kind of high in the other location. But for yield, here I would like to talk about this corner and also this corner. So for this corner, QU50 is here, and also Hanlock S11 is here. So that means the clones in this corner is showed high yield in Dongnae, where the CMD pressure is low, but show low yield in tannin, where the CMD pressure is high. And so this might be one possible reason. There might be some other factors like soil fertility, or some other environment factor there. And also this corner, these are the variety from IITA. So they showed good performance in tannin, but it's okay performance, or it's kind of just a so-so performance or yield in Dongnae. And then for the starch yield, the pattern is quite similar with the yield. And plant type, it showed very good correlation between these two locations. It's also kind of makes sense. It's high heritability trait. And then we combined the data together from these 2 locations and get the mean of the blue value. So this is the result of the 48 clones. I use color to show the good or the poor performance. In general, the green color is showed the good I mean the one we prefer, and the red color is showed the one the poor performance. You can see the checks. They don't have CMD resistance, and all the others is kind of less than, at least less than 2. So based on all this data we collected, we selected the top part. For other ones, we are going to test them in multiple years. I believe we have more than 5 trials established this year. So next spring, we are going to have more data about these clones. So here I'm going to kind of have a close look at the clones. We are going to we are going to evaluate them in more locations. So I think first let's look at the checks. So we know they showed CMD susceptible, and in generally, for sure, they have a good plant architecture. The branch number is very low, and also the height of the first branch is high. The yield is not, in general, the yield is not as good as the top varieties. So this is a mean from these 2 locations. And if we have a close look at the top 5 varieties, so the 419 is the variety from Africa. So it's it has been dominant. I think it's also a popular variety in Africa. It showed good plant architecture and also starch and also yield. And this one is the variety we find from farmer field during the survey, and it also showed good CMD resistance. Dry matter is okay, and yield is pretty good. And another one is also ITA clones, kind of show the dry matter, lower dry matter. The height, I'm not quite sure. Probably it might be too high. And the other 2 clones is from Seat. So 2416 is kind of showed good plant architecture, and dry matter is also good. Yield is not as good as the top ones. I think we can, if we have time, if you want to know the details, we can have a close look at them again. So here is just another way to show the starch yield stability and also the variation among the 2 locations. So this data is show the starch yield. So it's kind of the starch content times the fresh yield. And the Y is the different clones. And here the blue bar is the yield in the starch yield in Dong Nai, and the orange is starch yield in Taining. You can see the top clones. It showed a kind of large variation between these two locations. And here I want to point out this 442 is in generally good in the 2 location. It's kind of in the middle, and also another clones is also for sure it was further evaluation. And I want to point out Q50. There might be, I mean, it showed quite high variance in the 2 locations. So we want to so it's hard to make decision here or make some conclusion here. Let's look at the data we harvest next spring. So and also here is kind of similar information but showed in different ways. So it's good in one location but not good in the other locations. So so this is kind of the major result from the the introduced variety we have in Southeast Asia or in Vietnam. So now we are advancing these varieties for multiple location test, and also we bring the top clones to the cross industry to cross with the local elite variety. So the next I'm going to talk about the markers we validate, kind of briefly talk about that. The CMD2 markers, the first the QTL were identified by CED scientists, and we have SSR markers, and then later ITA they developed the SNP markers, and these markers are available in Intertech platform. That's a company in Australia, and Excellence in Breeding support this genotyping platform. So the price is pretty affordable. It's $2 per sample for 10 train markers. So there are CMD2 markers and also dry matter markers there. So I think it's it's good to run these markers to help us to fix this CMD2 gene in our population. So before using that marker, we have to validate to see whether it works in our breeding in our population in Asia or in CED population. So we use two populations to validate the markers. First is the Vietnam, we call it 142. And that's the clones we collected from farmer field during the survey in 2015. And the other population is the CED 102 clones is from TME3. So, and here again is the heritability, showed the data quality for the CMD score, 0.8 or 0.9. And so this is some top 10 CMD resistant variety from the local variety for sampled from farmers field, and their CMD score in 2 years, and we have checks here. So they have some kind of resistance, but it's not immune to CMD. So, and then from the CED 102 clones, we have 34 clones. It showed immune to CMD to CMD. Yeah. And then we have the phenotype data. Then we run the CMD2 markers through these two population. So this figure is showed the population CED 102, and this figure is showed the Vietnam local population. And there are two markers, is S112 and S12 and S14. So the Y is CMD score, and the X is the genotype. So we have two markers. So the first two letters is for the marker S12, and the second two letters is for marker S14. So for marker S12, so for these genotypes, there are 22 clones have the same genotype is GG. So they showed a very high, kind of high CMD score, and for these two markers, let's see. So the resistant alleles is T alleles for the marker 1. And the resistant alleles for marker 2 is A alleles. So we, based on this genotype, we can see this genotype it has one resistant allele, and this genotype also have one resistant alleles. So this showed a little bit better than the genotype without any resistant alleles. So, but there are also kind of high. A lot of clones it showed high CMD score. But for these three genotypes, if it has 1T1A or 2T or 2T1A, so in general, their CMD score is very low. So, this CL102 clones we know is from CMD2, from TME3. There is CMD2 gene there. So based on this result, we can see in segregation population, if we know the CMD2 the donor for sure, and also we know in the susceptible clones or susceptible varieties, there's no these T or A alleles, we can use this marker to help us to select for CMD2 genes. And here is the result from the local varieties, and we can see for the genotype we have the resistant alleles A, T, or T and A. So their CMD score is a little bit lower, but it's not as good as the ones in CL102 population. So that kind of tells us if in diversity population, these CMD2 markers might not work very well. So to implement these CMD2 markers, we have to know the genotype, the background of the parents and the CMD2 donors. So next, we are going to start some long-term breeding activity. So we made some Hanlock made some crosses last year, and they shared about 2,500 seeds with us. And then this year we are going to evaluate this population, kind of going through this cycle. So we plan to do a kind of quick recurrent selection to cycle back the best material from clonal evaluation trial, the third year, to the crossing nursery. And also we are going to use CMD2 markers to help us to increase our selection efficiency and also reduce the population size for next stage test. Okay, so I'm going to stop here using these figures about the performance of the clones in 2 locations. So we are going to harvest, I believe, more than 5 trials in Vietnam next spring. So we are going to have much better data to tell us which clone we might need to consider for the semi-commercial trial or for the first generation CMD resistant variety in Southeast Asia. Okay, so that's all. Now I'm open to questions. I hope I'm clear for all the points. If you have any question,
thanks, Xiaofei. Very interesting. I can see Eric.
Yeah, just a quick one. Thank you very much. Very interesting. Very good. Did you use any artificial inoculation or a way to ensure that CMD was high in one of the 2 places?
Oh, there are some echoes. So no, the whitefly pressure is pretty high in Taining, and also is good in Dong Nai even now. So they try to keep the disease very low, but the pressure is pretty good. No, there's we don't have any artificial inoculation in the field. So the whitefly.
So natural, but higher in Taining than Dong Nai.
Yeah. Just to
thank you.
There's spreader rows in between the.
Oh yeah, you're right.
Plots. So there's plenty of disease, but kind of following up on that question, and maybe Nyan or Tui has to answer this. The stems came from Taining, so they were already exposed before the trial, right? And what we're seeing from the trials in Cambodia from Rit and Imran is the yield kind of result is more determined by when like KU50 becomes infected. So at the end, I think in both sites, it was a score of 4, But was there any variation in the timing of when that kind of infection took off, and could that help explain the yield? I assume Tui might have to answer that, or Nhan.
Từ đây lên trung tâm cỡ 2 tiếng anh à?
Where is Nhan? Can you hear me? So the pressures in training, both training, the trial was established in the real field with the real conditions and pressures of CMD. So in training, more than 90% of the cassava areas over there infected with CMD.
Yeah.
Why in Dong Nai it is not the case. So yeah, that it is about the CMD pressure, that it is the real condition. And in terms of areas, because in training it is the intensively farming system where people plant cassava for the commercial purpose. But in Dong Nai, it is also not the case, and it explains why the disease and pest and disease in training on cassava is always higher than in any other provinces of Vietnam. And in terms of soil conditions between the two fields that we are doing, that we established the trials, and the soils in training and also in Dong Nai, it is totally different. In Dong Nai, it is very high organic matter. It is the red soil, while in training it is gray soil. It is very poor fertility. In terms of soil analysis data, we just got it yesterday, and I don't know exactly yet, but yeah, would know. What would know about that? The only thing I know is the dry, the organic matters in Dong Nai. It is about 10 times higher than the one in Tainan. Yep.
Thanks, Tui.
Yeah, and here, I don't know if you can see the slides. So there, in Tainan, you can see it start from 1.6 and it's kind of go to ladder slowly, but in Tainan is start from higher number. Yeah.
Yeah, I mean, I think that's probably it's an important point in terms of when we think about the importance of the clean seed system,
right?
And in which locations can you actually maintain it. So yeah, that's an important result of that graph there. Other questions? I can only see so many faces, but there's a button up the top to raise your hand if you have a question. Otherwise, just open your mic and force your way in. Okay, so we can come back to questions after Dr. Chirampol's presentation, because I think you'll see some fairly significant variations. I just wanted to, if I can show one thing before we do move on, just in terms of what this means. I've pulled this from Xiaofei's table. 5 tons starch per hectare. You know, if every farmer adopted in Tainan and got 5 tons per starch per hectare, we're talking $114 million a year in increased revenue at the farm level. So these results are not insignificant, and the demand for a solution is very strong. So with that, I'm going to ask Dr. Chirampol to present, and I'm going to try and bring up his presentation for us. Can you see a presentation from Dr. Chirampol?
Yes.
Yes.
Okay. And full screen in this platform would be page view. No. Maybe go ahead, Dr. Chirampol, and if I find it during the presentation, I'll change it. But tell me when you want me to move slides.
Okay. Good morning, everyone. Can you hear me clear?
Yes, good.
Okay. Let me presentation about breeding program in Thailand between KU and TTDI. Okay, next slide, please. Okay, this slide shows the data of 5 selected breeding line. This breeding line we get from the SSR marker and SNP marker screen with CMD2 between CMD spreading in Thailand. We make across commercial variety with TME3 and C30 and firstly selected by SSR marker and SNP marker. As you can see in the table, we plant the 5 selected line in the CMD spreading area, but in this experiment we have a small amount of stem or seeds that we planted in a single row tile. Each single row have 8 to 10 plants, and we score the disease symptom, disease severity, and disease incident, disease index every month before harvesting, and we have a harvest at the 10 month. As you can see in the table, in this table we have all data of selected line, but the other one will present the next. We can select just only one from 5 selected line. It named the number 179-4. Disease severity is 1 when compared with the resistant variety C30 is the same. No symptom show, and disease index is about 0. And the next is the convert to kilogram to hectare, about higher than Czech variety. It's about 800 kilogram per hectare, higher than C30, and not high for starch content. Starch content we measure by the Lyman scale. Okay, next slide, please. This data we evaluation of commercial variety in Thailand and compare with 330 TME3 and number 89 is a susceptible variety. And the other one line that we have the many number of stem 179-5, and we have a experimental design in RCBD with the 4 replication, and to make sure we have CMD pressure in the field, we use the 2 row of susceptible variety 89 each pot with the 2 row. As you can see in the Sakao province is the CMD spreading area, where Bong 60 and KU 50 has a low disease index and high yield compared with the TME3 and C30. These 2 resistant variety but very poor yield in Thailand, and starch content about Huaibong 60 is 22 and Huaibong 90 is almost 24. And the successible variety, we use the new CMD free to plant in this experiment. Okay, next slide, please. Journal. Oh, next slide, please. Okay, this is the result of 5 IITA variety that we have a few trial at TTDI. But in this table, we generally have four variety. The other one is TMEB 419. We will have a harvest 2 months later. TME IITA number 2205 has the highest yield, but starch content in this table is very low because we have a harvest after landing day. When compared with the Czech variety in the near field, Hoi Bong 90, the starch content is higher than for variety. It's about 23. This is the trial of IITA variety. Okay, next slide, please. Okay, this figure show the plant type in the field that we collect the data. In this field type, we use RCBD with the 4 replication. Each time we have collect 24 plants. This is a plant type of 4 variety that we plant in Thailand at TTDI. Oh, okay, next slide, please. And the other set of seeds that we get from seeds, we have we get it from 32 clone. And now next slide, please. And now it's in the process of multiplication in the tissue culture lab. We hope early next year, about March or May, we can plant it in the field at the TTDI. Okay, journal, next slide, please. And the set of resistant variety from resistant seeds from Hawaii. We get about 3,765 seeds from Hawaii. And now we make a germination in the nest house. The percentage of germination is about 32.2%. That means 1,200 seeds can germinate. As you can see in the basket, some cross cannot germinate well. Okay, next slide, please. And some cross it germinated very well, and we hope early next month it can go to plant in the field. Okay, that is our progress of breeding program in Thailand. Thank you very much.
Thank you very much for sharing that, Dr. Chuanpol. I've got one question before I stop sharing the screen. I hadn't seen this result, and I've only kind of looked. I'm not sure if it's. Were you seeing that the starch content was lower in plants that you were testing that were positive for the virus compared to the starch content of plants that weren't positive. Is that a result that you've seen?
Yes, if you see in the starch content, there are PCR positive and PCR negative. Positive mean we detect the each plant in the field by PCR, and PCR negative is the percentage of not infected plant. It's higher than positive.
Okay, that's an important factor in determining the impact of the disease. I'm going to stop sharing so that I can see people wanting to ask questions.
I have a question, to Professor Cherampol. When you say PCR positive, do they show the symptoms, or the plants were symptomless?
Some show the symptom, but in the some not show the symptom.
So
I think Dr. Wanvisa can answer this well.
Dr. Wanvisa, are you there and would like to comment?
Yes, we detect the, like Dr. Salompon said, that the PCR positive, we detect the one that are no symptom. And also in this result is plus between symptom and latent infection.
Okay. Thank you.
Welcome.
Other questions?
Yeah, I have several questions, John Cherampol. Yeah, thank you very much for your update. So I think from your report, is in general we can see that the starch content is lower. So can you please share your function for calculating the starch content? We make sure we use the same ones. Then we can compare our result for the starch content.
Yeah, okay. I think we could do that offline. We can make sure we're using the same equations for determining the starch content. Yeah.
Yeah. So for your first table, you showed you find the CMD resistant clones. So in that trial, is there any checks? The elite variety for checks? So there are how many clones? Yes. There are 5 clones. Which one is the released variety?
Again, my internet is delayed. Could you have my question?
So Dr. Cherampol is asking. So you have C33 as a check for CMD resistance, but do you have a commercial check that was in that trial, KU50 or Huibong 60 or anything?
Yes, we planned it in the same field, but not in the same experimental trial. If you see next, the slide is the same.
Oh, okay. So that means we can compare the result from these two tables.
Next slide, because we plan in the same field, but in different experimental trials.
Got it. So that means that the 179-4 seem like is in terms of yield it might be good, but diameter is still a little bit lower.
Yeah.
So how many? From how large the population you select to find these 4 clones? That's clonal evaluation trial, right?
You mean experimental trial?
Yeah. So you identify these 4 clones. So what's your base population size?
I don't understand your question.
Okay. So how big your F1 population?
Yes, F1 population, yes.
I mean, how many F1 plants?
Very small because
Early.
at the first we missed the resistant cone. The population about 70, but
okay.
There are some cause is small, but some cause is very big.
Yeah.
In the first, we just missed about the resistant and susceptible. Some is caught with the susceptible. At first, we just only get 5 cone from SSR and SNP marker.
Okay.
But for next year, we make a large population, about 5,000.
Wow. Okay.
We hope we will screen with the SNP and SSR marker again.
Okay. Nice. Thank you.
Okay, I'm going to move on and ask Rit just to quickly present the results from Cambodia. I think you will see a similar story emerge. Rit, are you able to share your screen?
Okay. Can you see, Jono?
Yeah, we can see.
Okay. Okay, good morning, everyone. I would like to present about the agronomy research trial in Cambodia that we conducted with our partner GDA. So for the first year, we have two kinds of research trial. So for first one, then density and fertilizer trial. We have different planting density. So and with also different variety recommendation. So if we see the zero fertilizer and with KU50, the yield still is good. As you see in the table, zero fertilizer is we can get around 34 ton per hectare, and the stack content is around 27%. Yeah, and you see the treatment one 10,000 plant per hectare with 80-20 and 80 per hectare. The yield is range from 39, to 48 ton per hectare, and the stack content is range from 27 to 31 ton per hectare. So this trial we use KU50 by selected the positive from the 2019 season. And if we have the good positive selection of the KU50 with the good management, so the yield can be maintained over 25 to 45 ton per hectare. This if we really have the good positive selection and with the good management, so the high yield could be maintained. At the end of the harvest, around 60% of the plant remain asymptomatic plant. As you see in the picture, this is the picture of the trial that we have harvested. So the yield is quite good. And another trial was harvesting time trial. There are 3 treatments. So we harvested at 6 months after planting, and 8 months after planting, and 10 months after planting. So the yield of the plant harvested at 10 months after planting provide the highest yield, but the starch content is a bit low than harvesting at 8 months after planting. Yeah, as you you are aware about the cassava which is bloom, recently it is happening again after a few years disappear. So last harvest this harvest season, so the cassava which is bloom is appear again in Cambodia, Kampong Cham province. As you see in this picture is very severe. This is happen on KU50. We have did the comparison by harvesting the 100% affected by cassava which is bloom, and another one is the healthy field that we did the positive selection, and the fertilizer recommendation is the same. So if we provide the good positive selection with good management, we still can get high yield, and also the starch content is also high. If you look at the right side, so the 100% of which is bloom, so the yields just still around 30 ton per hectare, and the starch content is around 25%. So this means like if we have the good positive selection with the good management, so the yield of KU50 could be maintained. And the cassava which is bloom so currently is not happen in Kampong Cham, and at the western part of the country border to Thailand also. I've got the report also the disease also appear again. Okay, this is just a short presentation of agronomy trial in Cambodia. Thank you very much for your listening. If you have a question, please.
Thank you, Rit. Yeah, so another two important factors introduced there that, again, we see if the disease pressure is not at too high a level and good positive selection and management, farmers can be getting good yields. Of course, the big challenge is where do they get that clean material to start with, an important part of the seed system component of the project. But also, I think the results of witch's broom also cause some cause for concern that we may be fixing one problem and introducing vulnerability to another problem. In terms of an update, the core collection is now in Laos, ready for the grafting experiment to try and identify sources of material. And we're also adding Dr. Wanwisa's lab into that experiment so that the Thai group can be also evaluating for witch's broom resistance in the new clones and that they are developing. But any questions at this stage for Rit, or we can move directly into the discussion points?
Jono, just one question. Why are you saying that witch's broom would be a problem that we caused by solving the previous one? Aren't they quite unrelated?
I mean, at the moment, most of the existing Asian varieties that we are saying are less susceptible to CMD are proving to be the more susceptible ones to witch's broom. So
okay, I understand then.
Yeah. So hopefully we don't have the same issue with the new releases. Yeah.
Okay, but you have no idea whether those candidate resistant that was discussed earlier, how they react to witch's broom.
Exactly. So we're starting to screen for that now.
Yeah. Okay. Yeah.
Is there other questions directly to the presentation? Otherwise, we can just move into a discussion.
So kind of a general question to raise. So the whitefly population is not very good in the testing station, or is in general is mild in Cambodia?
Yeah, by my observation, the whitefly population is not very high.
Okay.
But I have seen last 2-3 years at the beginning of the rainy season. Yes, it was very high. That time that I have seen.
Or it might be also affected by the environment, like the rainfall, the humidity, probably.
Yeah, but for last season, I did not see much in the field.
Wow. Okay.
That's an important point for Wilma's teams to be like thinking about, that whether we can get some information on whitefly populations through the season in the locations where we're doing the variety evaluations to help us make comparisons would be useful.
Yes. Okay. Another question about the witch broom. So, John, do we have any field is suitable for field evaluation for witch broom?
I mean,
we discussed that.
This year has been really bad in Cambodia and in parts of Laos. I don't think we have issue finding fields at the moment. So we had one trial last year looking at the impact of witch's broom on yields in Laos. I would like to move those trials eventually off station. The issue is, doing trials with large populations and data collection in farmer fields is kind of setting yourself up for failure if we don't have good control. And so Champkala, where Rit does his trials, is a great location for these trials. It's a big field, but we don't have the core collection in Cambodia. But yeah, let's see how we go this year. The grafting, I mean, this year was meant to be grafting for evaluation. I've asked the tissue culture lab to grow enough plants that if that fails, we can at least have some in the field to see if we can be picking up anything in that. But I think a separate call and discussion on the witch's broom screening is needed. Yeah.
Thank you.
Okay, can I ask Dr. Hum to make a comment in terms of what's happening in Vietnam with the ministry and the plans for release, and whether the results from today influence those discussions? Dr. Hum, are you able to talk to us?
Sorry. Actually, as you know, that we have a very high need for resistance material for planting, because CMD caused almost panic for farmers in cassava growing region in last years. And then we bring our authorities, provinces, and the mark to the field to show our variety from INTA. So they were very happy. They were very happy. Also, the variety we showed there, actually, I have to say that does not really meet the requirement of farmers. Why? Because in our farmer practice, they need not branching varieties. This straight and can resist high density of planting. Farmers grow about 25,000 plants per hectares, and they need 2-3 kilograms per plant is good for them already. So this is a farmer practice. Why they do such high density of planting? Because this helps them for controlling of weed controlling. And what they need also is a high starch, of course, because the buyer always reduced price when they test and they see that the starch content is not high. So, but nevertheless, what is disadvantage of the variety we show in the film, that this too much branching, so you cannot grow in with high density. The first, and the second, starch, low starch content, and the starch content fluctuated very much during season. So also quite challenging for farmers to define which time for harvest. Nevertheless, we decided to release that two varieties, HN3, HN5, because it somehow it meet farmers and authority expectation. In the field, when all the variety lost 40-50% of harvest, our variety stay there green, and the promise have a good, have better yield than all the variety. And in our plan, we try to offer farmers additional option. They will make own their decision which variety is better. All the variety with CMD or our variety without CMD. They will make own their decision. What is better for them economically? And in our plan, we are looking also forward to release more variety from INTA, from SIAT in a shade way. And it will come to plan to problem how to propagate it. How, because for example, for the release variety, we have only few hectares, and the demand from provinces very high. We have presently totally we have about 4 hectares, and our steam after harvest in Tây Ninh, in Dong Nai province, farmers also take over and plant it somewhere. So it means that we need to have a technique for fast multiplication of the variety, and the tunnel system is one of the option, and the tissue culture is one of option. We Ministry of Agriculture are willing to support us with a project for propagation, but with quite crucial conditions. Why? It need for extension project, you need to cover 4-5 provinces, and by the end of project, you have to show that in each province at least 100 hectares of new variety, which we cannot meet now. So we have to wait to the next year when we have more planting material and work further for 2-3 years, and by the end we will meet the requirement of extension project. And eventually, members of cassava association become interested in our work. They approach us and asking for collaboration. I think that in next time they will take over some part of the propagation work, and I hope that some testing work they also take over this part and working with us. And the provinces, a number of provinces approach us asking for planting material, and we were delivering planting material of new variety to several provinces, and they are testing in their location by the same way they are propagating. And I hope that by the end of 2022, the acreage of new variety will be enough to meet demand of the provinces. So far, but I have to say that this still short term. We have to work on long term, that introgress resistance gene from that material into local variety, into localized variety. I think only that in that way eventually we can meet the expectation of production, expectation of farmers, like high starch content, high density of planting, and the economic value of the cassava. Thank you. So far, I want to update to you.
Thank you, Dr. Hum. It's very useful to hear that there's interest both from the public and private sector. As I think you're aware, I'm turning a lot of travel money of the project into supporting the rapid multiplication in a variation contract at the moment. But I think you made the point about maintaining options for farmers and ensuring that farmers can switch to an existing variety that's being sourced from outside of the infection zone is critical, that we maintain access and options for farmers. I wanted to show one slide I remembered from a presentation from Henan many years ago, and then ask Augusto and Xiaofei to comment in terms of how we screen varieties. I mean, we know some varieties starch yields fluctuate quite considerably during the year, and depending on when you harvest will be the result. And then Tay Ninh and places in Thailand where there's all year round harvesting and processing. Do we need to think about how we screen for starch content through the year? Should we be looking at irrigation to get a response to see how stable the starch yields are? Augusto or Xiaofei, would you like to comment on where we are in understanding starch stability and methods?
Yeah, so that's
You're on mute, Xiaofei.
Sorry about that. I think the short answer is we don't have the protocol to measure that for the breeding populations. That is, so we know the dramatic stability is very important. We need to develop that protocol. So I think your idea using irrigation to have several harvests, that would be great. to understand the dry matter stability for advanced material. So, yeah, I don't know whether Luis goes to have any other comments. So I talk about I talk this topic with her name. So he, you know, that figure is just showed several varieties, and we're for us we just do it in the very late stage. For example, we have 2 or 3 variety is about to be released. We have different harvest to see the dry matter, the variation of dry matter, but we don't have the protocol to screen that in a kind of in an artificial environment. I believe your idea, the irrigation helps. Luis Gusto, sorry.
Yeah, no, thank you, Chofei. That's I mean, that's a very fair comment. The only thing I need to I should add, Jono, is that in terms of dry matter content measurements, one of the major advances we have made are in 2 fronts. One is certainly on the phenotyping of the starch content using NIRS. So this is data that is currently under evaluation and an analysis. So we should be able to have a good way to measure starch content using near infrared technologies, and that will allow us to track starch content not only at harvest but probably at different points in the growing cycle. But certainly one of the other advances we have made is on identifying germplasm that consistently presents high and stable levels of dry matter content, and this is not only in the breeding program but also in the land races. So I think it's promising. The limiting factor has been to get enough momentum to put the team to concentrate on getting the curve, the near infrared curve finished. But this is underway.
Thanks, Augusto. Any other comments or questions at the moment? Dr. Chilampo, could I ask from a Thai perspective, for the IATA clones, like what's the next step? Are you evaluating those in different locations, or are you throwing them out? What's the next step from Thailand?
For IITA cone, diameter content and starch content is, I think, it's lower than commercial variety now. But for our team, we will test again in different places in Thailand in this year, and use the commercial variety as a check again. But IITA varieties, resistant variety, we will make crossing with the commercial variety and test it in different many locations in Thailand. Before our team release new variety, Dr. Jalern Sak, he has the test 50-60 locations. I think before we release new, maybe we should make a try many locations. But for IITA, we will take many places before again.
Yeah, I think that's a important opportunity, and I know Xiaofei started this work to try to map different agroecological regions where these multi-location testings are occurring, and then we can infer some of the results across country boundaries. So maybe that's something we can discuss later. I can see Wilma's got a question. Wilma.
Hi everybody. Thank you for sharing all this very interesting information. I want to confirm something. Jono mentioned after Xiaofei's presentation that the seed material for the Dong9 and Tainan trials came from Tainan. Is that correct?
Yeah. From CR 102 for sure. That's from Tainan. So I need to double check. Is Tu is there? So he might be able to. So he managed all those trials. He might have the detailed idea. Yeah.
Okay. Just so in a way you started with the same, let's say, incidence of infected material, if there was some infection in the original material. Is that right?
So Dewey, can you please comment?
The screening of 102 CIAT clones and 5 IITA clones from the in vitro planlets was established in training. And the input, that it is the clean in vitro planlets multiplied from in vitro, brought from Hanoi to training. It is the first screening. And then we collected the stakes from that fields in when it reached 7 months to establish the following 2 trials in May, same month, in May, and one in Taining and one in Dong Nai. That it is for the CIAT clones and IITA clones. In terms of the control, you
continue, please.
Answer your. And in terms of control varieties, they are virus-free stem. So KU50 and HLS11, all the control variety, it is disease-free, like a virus-free, were used for these two
trials. Yeah.
All right. Thank you very much.
That's an important question, and I know Joe's been asking us to think about infrastructure that's required if excellence in breeding has some resources, and whether like greenhouses to grow, material in net houses before trials is possible, or do we bring stems from other parts of Vietnam to ensure that you're starting with disease-free material to start with? But I guess over time farmers will be planting material from the field, so it needs to perform under those conditions as well. So any other questions in terms of what's happening with recommendations next year? I guess in Cambodia, from what we see, we're probably sticking with the trying to multiply KU50 and other less susceptible varieties in the rapid multiplication systems. In Laos, we've got a bit of a question to answer, in that we were, of course, originally multiplying Rayong 11 when witch's broom was our main focus, and now I've got concerns about distributing Rayong 11 in areas on the frontier with CMD. So at the moment we're multiplying both KU50, Rayong 11 and Rayong 72, and hoping to source Huibong 60 from the Thai team early next year. From a Thai point of view, Jerome Paul or other from TTDI, in the rapid multiplication at the moment, are you mainly focusing on KU50 and Huibong 60, or what's the strategy in terms of your rapid multiplication at the moment?
At the moment, rapid multiplication, he do waxy variety. Now that you see in the Facebook, they make a multiplication waxy variety now.
Okay, interesting. And are you seeing resistance? Have you got resistance in the waxy at the moment, or that's why the focus is on waxy to try and keep clean material going to the contract farmers?
They have two main. I think one is the waxy, and the other one is the normal cassava variety, and now he point waxy variety because no support from government.
Yeah, understood.
Resistant variety. I think Dr. Vichan can explain in this detail. In the Facebook that you see in they make many multiplication of variety. That variety is the waxy cassava.
Okay.
And normal cassava too.
Rit, I can see you've got your hand up, please.
Okay, thank you, Jono. Yeah, I have a question regarding to cassava variety from Thailand. So I have a question to Dr. Champalan. I aware of now for many cassava farmer in Cambodia, they have got KU-72. Yes. So last 2 years there are just some farmer in the western part Cambodia grow KU-72, but now I think this variety already spreading to other growing area of Cambodia. So do you have any comment regarding to this variety, please?
No, I don't have the data of KU-72. Is it go well or high yield?
Yeah, by seeing the post of the farmer in the Facebook, yeah, the years should be good. That's why other farmer they order to buy from that farmer at the western part of Cambodia to other provinces. So yeah, because your other partner they asked me, do you know information about the KU-72? So I don't have any information to answer them. So that's why I would like to know from you if you have
I don't
information.
Have more information. Sorry.
Okay, thank you.
Yeah, there's a few new varieties
popping up.
up.
Contact directly to someone.
Okay, so I'm aware we're at 10 o'clock and people in Asia and 10 p.m. in Colombia, and people may need to go to their next meeting. So I might call a conclusion there and thank the presenters and those who participated in the discussion. I also want to make sure we thank all the people in the last 12 months who have implemented the trials in difficult times during COVID. So please pass on our thanks to your researchers and field staff. And as you establish new trials for the coming season, please stay safe, take precautions. If you need equipment, please contact us to make sure you're all safe. Thirdly, this has been a great opportunity to share information. I'm very sad that we don't get to do it in person, but please continue to ask questions, share information through social media or emails with the team, because we learn a lot from those interactions. And finally, we'll be coming up to the reporting period, and so reports will be due, but I'm hoping that we can have a few more webinars from other components in the coming 2 months, so that we're sharing information that's also useful in those reports. So you should be getting some emails about reporting and financial reporting to country coordinators. So yeah, we look forward to hearing about your experiences. And if you do have something you want to present, please contact me, and we can work an agenda for you to be able to share that with everyone. So with that, if there's no other comments, thank you very much, everyone, for joining another really interesting session, and look forward to hearing from you and hopefully seeing you all again soon. Thank you.
Thank you.
Thank you, everyone. Thank you, Jono.